Wait. Check. We didn't send the presentation yet. No, I sent it to Dana, but I can give it to you now. I have it on right. Okay, if you prefer USB. Five. No, four. Ice, triple SSD. Going? Yeah. Okay. Okay. Yeah. Okay. Because I can find a thing on your website to upload. CMT, I think there's no link to upload. I sent it to Dana yesterday, but maybe she's very busy. I think so. That's why I said it's okay. Можно начинать. To do it or which fix it? Yeah. It will be before possibility. Yeah, before possibility, right? Okay.
Hello, everyone. Welcome to section 4, Data Science and Advanced Analytics. We may start proceeding with presentations, starting from ID 161, Javed Hossain, image captioning with PCO optimized ResNext. Time requirement is 6 minutes for presentation and 1 minute for question and answers session.
Thank you. Can you hear me?
Yes. Thank you. Can you share your screen and you can start?
Can you see my screen?
Yes, we can see.
Thank you. So,
Your time starts now.
good afternoon, everyone. This is Javed Hossain from Nanjing University of Information Science and Technology. Today, I'm going to discuss about my research topic. My paper ID is 161. Image captioning with PSO. PSO based on particle swarm optimization based optimized ResNext and custom transformer architectures. So when you want to be in research, you need to find out the problem, what kind of problem you want to actually solve. So here I shot out of top 6 problem statement I want to solve, and I have found this existing research, they have some limitations, then I create this problem statement. So number 1 is suboptimal features extraction in image captioning. For the image captioning task, one kinds of sequence to sequence learning, you need to find out some images, important features from features, and also at a time simultaneously you need to translate the created generated caption. So for this moment, you need to find out optimal features from images. This is the challenging for the image captioning task. But recent worker, they have sometimes they struggle with find out optimal features from images. That's why I have mentioned here. Inefficient model configuration selections and also limited contextual understanding in caption generation. Contextual here, I means that the actual our caption is NLP tags, some lemmatization, streaming, and backup words. Lots of technique I have applied for the create the caption. And inadequate attention to diverse image regions and performance gaps in benchmark metrics and high computation complexity in architecture optimization. Now, objective. Objective means, I mean that which are actual contributions in our paper. So I mentioned one by one. Enhance visual features extraction, automate optimal model configuration, improve contextual understanding in caption generations, enable attention to diverse image regions, and also achieve state-of-the-art performance metrics. It's in terms of value score, value from bilingual evaluation understanding, and method score and GALU score. Based on this evaluation metrics, I just evaluate my research and compare them existing works. Achieve state-of-the-art performance metrics and also reduce computational complexity in architecture optimization So this is the overview of my proposed pipeline. You can see there's in input images, and I used Flickr 30K image is available in publicly available in online, and I download this dataset and using optimized ResNext architecture. In ResNext architecture's backbone basically use 4 ResNext layers, and in terms of ResNext layers, they are used some ResNext block. So ResNext block and cardinality for find out optimal ResNext block and cardinality. That's why I applied PSO, particle sum optimization algorithm. This algorithm basically helped to me find out optimal value of ResNext block and cardinality. And this is the feature extraction, and this is encoder. Finally, I create a sequence of caption. What sequence and set, and there is training and validation and testing sample, and this is the sample images. And this is basically a ResNext architecture. ResNext architecture basically contains 4 ResNext layers. And here this is the ResNext block. Here I mentioned 8, but in my research I have used 32. 32, this means 32 group. Simultaneously, total 32 groups applied in ResNext block. 32 ResNext block in simultaneously apply one by one in 32 group. 32 group means your model understand in complex patterns and complex features from your during model training. This is the help for your model learning, and also in terms of accuracy, in terms of other real-time applications and each and everything. And this is my proposed ResNext architectures. Here you can see that I have applied total 32 cardinality. That means 32 groups simultaneously, 32 block one by one. And this concatenations each and every 32 block, then it will we will find out the optimal value. And I think so. It will be better performance than existing one. This is my PSO based optimization. How to actually PSO? I adjust with my transformer architecture. There's a little bit pseudocode or algorithm. Here you can see that number of particles and maximum iterations, and also search space boundaries. Here I applied 4, B1, B2, B3, B4. Here B1, B2, B3, B4 represent the number of ResNext layer, and boundary is 1 to 10. That means 1 to 10 ResNext block. It can be randomly taken by the PSO architectures. It can be 8, 6, 7, something like this. So finally, output is optimal value of B1, B2, B3, B4, and C. That means B1, that means first ResNext layer, number of how many number of ResNext block contains in our ResNext layer. This is determined by the PS layer. And C is the basically cardinality. And this is our evaluation fitness value. And this is update particle and waste value. We use update velocity using the how to say, this is the velocity formula. Here you can see the C1, R1, and P is our population, X our actual input, C is basically weighted, and R1 is velocity rate. So then final condition, if choose the match with this condition, then update the PI. Otherwise, we set global waste is equal to PI. These are transformer architectures. It's existing or traditional. Thank you. This is existing transformer architecture, and this is custom transformer architectures. I just a little bit customize in this architecture using extra multi-head attention mechanism and base normalization layer. Basically, why I use base normalization layer? Base normalization basically reduce the overfitting and underfitting problem. And at a time, multi-head attention mechanism basically focus on the important features on your images during the image captioning moment. And this is my result section. You can see that I got optimal accuracy and state of the art performance existing on others one. I got 79.17 value 1 scores, and the matter score is 28.63. This is my real life visualization. Thank you. That's all.
Okay, we may proceed with questions and answer session. Does someone from audience have any question? You are more than welcome to ask. Coming forward here. So let me ask you then. Did you consider any other architectures other than ResNext? And can you justify the choice of this model or architecture in comparison to other possible solutions?
Basically, I've used convexness architecture, ResNet, MobileNet, V2, lots of architectures. But after that, I evaluate my model using for my research purpose, using this free architectures and customize using my data sets, but I got optimal accuracy when I applied ResNets. That's why I choose ResNet architectures. And also researchers find out the optimal accuracy when they fit-train their model using ImageNet data set. They got optimal accuracy when they applied ResNet architectures. So in this consequence, that's I have used ResNet architecture for my research.
So considering your results and like research outcomes, what are your future perspectives regarding research? How would you continue it? What are you planning to do further?
Okay, I understood your question. So my future plan is basically going to do using Vision transformer and transformer architectures, some little bit modifications and combination with transformer architecture with the evolutionary computation-based optimization algorithm. Both are combinations. And also I want to do increase the data set, MS COCO and Flickr 30K is existing data set, but in terms of data set contribution and model, implement the model is innovative architectures. Both are my future plan in terms of data set, in terms of model.
Okay, thank you for the information. Thank you for your presentation. It was very informative. We can proceed with next presentation.
Thank you. Thank you.
You can stop sharing your screen and camera. Let's proceed with presentation with ID 166, Adelia Bikturova. Are you here?
Good afternoon. Yes, I'm here. Can you hear me?
Yes, we can hear you. Can you please share your screen?
Okay, 1 second.
And your camera, please.
Okay, 1 second. One second. So now you can see me and my presentation, right?
Yes, you can start.
Okay. So, good afternoon, conference attendees. My name is Adelia, and it's my great privilege to represent Kazakh British Technical University today alongside with my co-authors, Alibek Bisimbayev and Nasil Mukasheva. We're honored to represent our research titled MRI Brain Tumor Classification, Application of Various Data Augmentation and Techniques on ResNet 50. So let's start. Brain tumor stays one of the most challenging health problems in medicine, significantly impacting patients' life and quality, patient outcomes and quality of life. According to recent data from the World Health Organization, over 250,000 deaths annually worldwide are attributed to brain and central nervous system tumors, emphasizing an urgent public health concern. Despite significant technological and therapeutic advancement in neurosurgery, radiation therapy, chemotherapy, and etc., survival rates of brain tumors remain disappointingly low. In response to these challenges, our research addresses the potential of machine learning models, specifically focusing on the ResNet 50 neural network, to improve accuracy and reliability of brain tumor classification from MRI images. Central to our study is the examination of data augmentation techniques and their effectiveness in enhancing the performance of deep learning models. So here you can see just the stage of brain tumor progression. As you can see, it affects very greatly on the brain and nervous tumor system, and can be the cause of different symptoms, including headaches, seizures, etc. So for our analysis, we used a publicly available dataset compiled on Kaggle titled Brain Tumor Classification MRI. The dataset compares with more than 3,000 MRI scans organized into 4 diagnostic categories with brain tumor and with no tumor. During data analysis, we encountered significant class imbalance, notably within the no tumor category. So this imbalance reflects real-world scenarios where assembling medical imaging datasets can be constrained by practical challenges, including patient privacy, ethical considerations, very time-consuming labeling by the therapist, and resource limitation. So here you can see that the no tumor class has less data in the dataset. So in order to address this problem, our methodology adopted a systematic and structured approach, integrating various data augmentation techniques with ResNet 50. So here you can see our workflow. Firstly, we perform data processing, then we trained our ResNet without any data augmentation, and then we applied different data augmentation techniques. After that, we again trained it, and after getting the results, we then compared it and discussed it. So for the, in order to see the changes in the performance, we used four main formulas, metrics. First is accuracy, second precision, recall, and F1. All these measurements usually are like the common metrics that are used in order to evaluate the performance of the machine learning models. That's why we use them. So going to the results, we can see that so here you can see that the first graph represents accuracy, second precision, third is recall, and fourth is F1 score. The first bar represents no augmentation. It is the results of the training and testing when we didn't apply any data augmentation, and the other bar charts are representing different types of applied data augmentation like flips, increased sharpness, scaling, translation, and then we combined some of the data augmentation types like scaling plus rotation, scaling plus translation, and etc. So here you can see the result. The results of our experimentation demonstrate that specific data augmentation techniques improve the classification performance. Of course, it's not like very like big improvement, but we still see the changes in the positive way. But because of the complex problem of the not available data in medical classifications, this problem still remains like very leading. That's why we perform like these data augmentations. And as we can see, we observed that the image sharpening and translation-based augmentation delivered the best outcomes, achieving 80% of accuracy and 79% of accuracy respectively, as you can see here. So it's these findings underscores that a very specific and very accurate, very like very good like calculated data augmentation can help us to improve the performance of the ML models. Conversely, we found that overly aggressive or compiled augmentation strategies can negatively impact on the results or didn't impact at all. That's why it's important to choose a very like not very aggressive data augmentation techniques in the medical field, particularly, especially in the brain tumor classification. So this outcome highlights an important consideration that while data augmentation can enhance robustness and metrics, still the optimal balance must be maintained to preserve critical diagnostic characteristic and MRI scans. So that's all.
Adela, thank you very much. Any questions? Can you come with the microphone?
So thank you for your presentation. I have a question about why did you use ResNet 50 over other CNN architectures?
Yes, I used specifically ResNet 50 because it's a robust pre-trained CNN that already showed a good results in classifying different medical images. And also in the ResNet family, we have other ResNet models like ResNet 18, ResNet 50, and etc. And I choose specifically ResNet 50 because it shows the most it showed the most stable results during training, and also in comparing to ResNet 18, it showed more stable work, and in comparison with more advanced ResNet models, it showed a very optimal computational and time like taking for the training and testing. It was not very too complex because our data set is not very big, so we don't need a very complex model.
Thank you for your answer.
Okay, I have the question.
Adela, one more question. Any questions from all?
Yeah, it's me.
Balasha Gafurna.
I see that you've mentioned here the most admissible way to make the augmentation turns to be translations and increasing the sharpness of the pictures.
Yes.
Yeah.
Yes.
But actually, I'm quite surprised why you didn't apply with that two methods the flip, because the flip looks like the most natural way make the the reflection left side to the right side, so it's looks to be the most natural way to make this kind of augmentation. But you mentioned that only that two, increasing sharpness and translation, gives the better results.
Yes, in our experiments, these results showed the best. These data augmentation types showed the best results. I think the flip still showed a positive, like positive improvement in the accuracy, precision, and etc. But the best one was translation sharpness from our experiments. I think it's connected with that when you flip images, still some data maybe can be not delivered as good as it was on the original set, and maybe because of the flips, the data was not very like diverse still, because only flips, maybe it was.
Well, sorry, actually you make some guesses, but you didn't check it accurately, specifically the flip translation, I see from your answer, yeah? Because just now you just say maybe, but not the actual facts, yeah?
No, we performed experiments with flips too. As you can see.
I see here you make flips,
yes,
just
flips.
solely the flip uniquely, but flips plus, for instance, sharpness, or maybe flip plus translation. So you need to make different combinations of this kind of augmentation. Okay, thank
yes,
you. I do not have additional questions.
Okay. But in the last experiment, we performed crop and flip, and it showed positive improvements too. Thank you for the question.
Thank you. I do not have questions.
Thanks for your insightful presentation. We may proceed with the next speech. You can stop sharing your screen and camera.
Okay, thank you all.
We proceed with ID number 167, Syed Masuk Ahmed. I hope I pronounced it correctly. Are you here?
Yes.
Are you ready to share your camera and your screen?
Can you see?
Are you sharing your screen? We can see you.
Okay. Can you see my screen now?
Yeah, we can see. You can start.
Okay, thank you. Good afternoon, everyone. I'm Syed Mashuk Ahmed from Nanjing University of Information Science and Technology, Nanjing, China. Today I'm gonna present our topic is unit-assisted farmland detection with a convolutional block attention module. Me, Syed Mashuk Ahmed, my co-author is Javed Hossain. What is a remote sensing image segmentation? Sensing image we can collect through satellite or drone footage, anything. Then we are dividing those images into distinct region and objects, such as it can be farmland, forest, or urban areas. And then we are processing each pixel into an image to a specific category based on its feature. Project scope. Our goal was to create a deep learning-based segmentation model that can accurately distinguish farmland from non-farmland satellite images. So here we used total two classes. One is farmland, and the other objects will be taken as a non-farmland. And here we used a total two kind of architectures. First one is UNIT. It's a CNN designed for image segmentation, utilizing an encoder-decoder structure with skip connections. And to refine the result from UNIT, we used attention module. It is a CBAM, convolutional block attention module, an attention module that enhances focus on critical regions and boosting segmentation accuracy. And here are some challenges we faced in this project. I can divide it in three parts. The first one is precision farming, map farmland boundaries to optimize water, fertilizer, and pesticides used, disaster response, identify farmland affected by floods or drought for targeted recovery, and then land use mapping. You can monitor changes in agricultural land for policy and planning. And here are some issues with the traditional image processing methods. It's like low adaptability. It struggles with variations in lightning seasons and terrain in satellite images. And also it requires domain expertise and it's time consuming. And then poor performance in complex or noisy datasets, and difficult to handle large scale or diverse dataset effectively. Here's a little or a dataset overview. Dataset, the source, I already said, we are collecting satellite images, and pre-processing, we are converting it to a binary mask. Then we applied some normalizing techniques, then shuffle images for better training, and then data augmentation, and the last one is splitting. And a few key statistics about our dataset. We are using some images containing 512 into 512 resolution, and total training images we have almost 6,000, and testing images 1,453. And the class I already said, we have two classes here, farmland and the non-farmland, defined as red and black in mask. Here you can see the red parts defining farmland and the black parts defining non-farmland areas. Okay, here is a little about image pre-processing. You can see for better training, actually we converted all the masked images like black and white to black and black and red to black and white. Okay, so here's a little comparison with other architectures. You can say why we used UNIT.
Have 1 minute.
Okay, so here you can see FCN improve the understanding of most complex sequence pattern, and also it has weakness course prediction like fine grain details, and then SegNet. It is therefore low memory requirements suitable for real-time use, and also struggles with complex boundaries or small objects. And then we have DeepLab 3+. It's excellent accuracy, multi-scale feature learning, and also the weakness, high computational cost and slower interference. And here, UNet with CBAM, what we used, it can accurately do the segmentation, integrates an attention mechanism, but we have some drawbacks, slightly higher computational complexity than the UNet only. And pros and cons about UNet and CBAM here we used. For UNet, the pros we can say like encoder decoder is designed with escape connections and computationally efficient and works
I'm sorry,
well
can you
on
move to the
small
computer?
data set with data augmentation. And for CBAM, it enhances models adaptability to focus on into any kind of CNNs. And the cons, the UNet struggles with learning hierarchical features alone, limited performance for dataset with the complex global contexts. And CBAM introduces slightly computational overhead, may not add significant value to non-complex tasks. But if we combine those benefits of both UNet and CBAM, so UNet handles localization and reconstructions, CBAM ensures the model focuses on relevant spatial and channel level features, boosting the segmentation accuracy. Okay, so I'm gonna explain about the UNet diagram now. Here you can see we are inputting the input image first.
Said, I'm sorry to interrupt.
Here.
Can you please quickly sum up your presentation? Time's up.
Unfortunately, we have time limit.
Okay, I'm trying to finish it quick. So in the UNet diagram, we have total 3 parts mostly. The contracting path, bottleneck in the middle, and the last one is the expanding path. So in short, the first encoding part, it is reducing the overall resolution to process faster, and also increasing the features. And the bottleneck part, and then the decoder, it is just doing the opposite of encoder. Okay. And here's the CBAM part. Here you can see we are first inputting the features from CBAM. And then there are 2 parts, a channel attention module and a special attention module. And the last one, we are getting the refined features. So I'm just giving a short review of CAM and SAM. Here, first we are inputting, then we have 2 layers, max pool and average pool. Then it is going through the shared MLP. And we have 2 blocks for channel attention. The outputs of the result we're getting for MLP are passed through this sigmoid activation. And then we are getting the final output.
I'm very sorry, Said. Time's up. We move to questions and answers.
We have time limits because we planned 10, 11 presentations.
Okay.
Before, then we unfortunately should keep our time limits.
Okay.
Okay, then maybe questions for Said?
I have the only question.
Please.
Okay, actually, you know that satellite images can give us different variety of the channels. For instance, most of the available channels are 8 different channels. But in your analysis, did you make this analysis for each channel and just choose the most appropriate channel of the picture to make the analysis? Because you've mentioned the RGB images in the JPEG format, and I see it's just in 3 channels RGB. But did you make this kind of analysis just to choose the most appropriate channels for your analysis?
Okay, thank you for your question. Actually, we are taking the RGB images. Those have 3 classes, but we are converting it to grayscale image. There we have only black and white. So if I say like it's a binary classification.
Oh, okay, I see. So you didn't need another channels up to 8 for instance, when you
Yes.
download the images, you just downloaded the RGB parts, that's 2, yeah?
Yes.
Okay, thank you. I know have another questions.
Okay.
Any questions? Okay, then thank you, Syed Ahmed. Let us proceed to the next presentation.
You can stop
Thank you so
here.
much.
Thank
you so
you for
much.
that.
For the next presentation is ID 173. For the next presentation is ID 170, Olga Salovey from Kyiv National University.
Yes, no, let me share my screen one second, please. Is my screen visible?
Visible, yeah, but sound some
Yes.
trouble.
You have a trouble from sound quality from your side.
One moment. Is it better now? Can you hear me?
Nothing has changed, unfortunately.
Sorry. Is my screen visible? My apologies, not. I see I'm sharing. Can I no?
Screen is visible. It's okay with the screen, but sound is not good. Very hard to listen to your speech. Volume of sound is good, but quality of speech very.
Can you hear me now? Is it better now?
Now it's good. Now it's good. You can start.
Thank you. Thank you. Thank you. Let me introduce you the work that discrete bias network model for diagnostic latency, the growth in Apache Kafka cluster with information system for building and construction architecture. IoT devices, sensors, and wearable devices have become data sources for information system in construction. Consequently, the architecture of the system has changed to include the streaming process engines such as Apache Kafka, which is served as a distributed storage system. As a Kafka cluster is a highly configurable, so the selection of the proper configuration is a measure uncertainty which affect Kafka cluster efficiency. And this efficiency is measured by end-to-end latency, which is the period of time from the moment when the producer sent event data to the server and consumer is able to fetch this data. Therefore, models and methods are required to diagnose and evaluate the efficiency of a Kafka cluster to be able to include when it is included in the information system for building and construction projects. Machine learning models are powerful tool for approximated input-output relation when solving regression classification and clusterization tasks. However, those models often lack ability to explain how decisions are made, right? In contrast, bias network is a tool to create a model, perform a sensitivity analysis to understand the strengths of the causal effect by evaluating how changing one parameter, let's say, of the model impacts the target node. So bias network, in addition, bias network enable the incorporation of domain expertise, technical knowledge that helps put and focus on the most important feature. The goal of our research is to propose a discrete bias network as a probabilistic model for diagnostic end-to-end latency growth in Apache Kafka cluster when it is by simulating the effect of changes in the cluster configuration. To develop the bias network model, we to achieve our goal, we developed a bias network model, and we studied the created model to verify its ability to diagnose a Kafka cluster latency. To create the structure of a bias network model, we use a technical knowledge of Apache Kafka architecture, which on a high level includes three main players. It's producers, servers, and consumers. And when producer sends event data to a server, then it is first stored in the socket receiver buffer, then it is put in the shared queue from where it is taken and noted in the commit log, and after is saved on a server leader disk. Save event data on the server leader is put in the purgatory map queue, where it is waited until a replication of this data on other servers, which is often referred as brokers, is completed. The replication solution approach in Kafka cluster is a main solution to ensure the durability of a data sent on a cluster. Once the replication is completed, then this event data from a purgatory queue is moved to the socket send buffer, and from this point, producer received the response from a server leader, and data is saved successfully, and consumer is able to fetch data to consume the data. Based on the above, the end-to-end latency formula consists of 4 terms. Basically, the first term is a producer time, the time needed for producer to gather data in a batch. Then there is a period of time when, from the moment when data is received in the receiver socket buffer and before it is saved on a disk of server leader, it is a leader commit time. Then there is the replication time, the moment from the data is saved on the disk of a server and it is copied on a brokers or on a server on other servers. And finally, the period of time once a producer receives a confirmation from a server and the time the data is fetched by consumer.
I'm sorry, Olga, you have 1 minute. Can you please
Of course,
conclusion?
Of course. Having analyzed this above, we define the structure of a bias network. So the zero level is a level with observed variables, then 2 hidden variables, values of which we do not know and are impacted from the above, and finally our target. Then this is the first part of construction bias network. Second part of the construction is to specify the probabilities and conditional probabilities. We use the maximum likelihood estimation algorithm to get this together with the dataset. Dataset we gathered as a result of specifying different test scenarios to test cluster under with different goals. Then we presented the observed variables with states and possible values. Then we associated these states values with scenarios, executed tests, and received the measures and latency. This next slide, on this slide, is presented our finally developed bias network, and we performed the test. So basically, our first layer with observed variable had been set a state which correspond to one of the scenario, and then we verified that the end-to-end latency is predicted according to our theoretical result analysis. This having this test verification, we concluded that our proposed bias network is able to predict the latency, and we can recommend to use this bias network when Kafka cluster settings are needed to be optimized for better performance, to predict potential points of failure or bottleneck. The future study will be focused on the development of a sensitivity analysis model based on the developed bias network. Thank you for your attention. Any questions?
Let's proceed with questions. Does someone from audience have any questions?
Okay, hello. Thank you for your presentation. So my question is, why did you decide to use Apache Kafka? For example, not RabbitMQ or like any other message brokers?
Yeah. this is because as I mentioned, Apache Kafka is very efficient, and based on our document analysis and research analysis, it overperform other similar engine to gather the streaming data. I'm emphasizing on the streaming data from different producers to the layer of a system architecture. So based on our document analysis, research analysis, we concluded that it overperform other agents. Thank you for your question. Any other questions, please?
How would you evaluate the performance of your Bayesian network model? Like which metrics did you use or will be using?
Yeah.
in the future?
In current work, we compare the prediction, the prediction of a Bayes network we develop with our test, with a result of end-to-end latency that we actually received during our conducted experiments. So here we just compare result. In the future work, when we are going to develop and work with the sensitivity analysis, we are going to use measures or scores like likelihood function and similar measures to compare the effectiveness of our models.
Thank you very much for your presentation, for your answers. And let us proceed to the next presentation.
Thank you.
Thank you for your time.
For the next presentation, we invite presentation with ID number 176, Andrei Onyushenko, Taras Shevchenko National University.
Can you stop sharing your screen, Olga, please? Thank you.
Good afternoon, dear colleagues. Can you see me?
Yeah.
Thanks. Can you see my screen?
Yes, we can see. You can start.
Thanks. Good afternoon, dear colleagues, dear chairman, organizers of conference. The topic of my report is modeling of the dynamic marketing equilibrium on the context greenhouse gas emission restrictions. The aggravation of environmental problems increasingly attracts the attention of scholars, politicians, and citizens. Since the first call to implement climate protection measure, numerous scientific researches has been conducted in various areas, and the need for supranational cooperation, interdisciplinary analysis, economic motivation, development, and legislative framework, etc. in ecological protection has been realized. Summarizing the main provisions of the efforts made in this area at various levels, the following main conclusions can be drawn. Climate change is one of the main environmental challenges facing the humanity. The anthropogenic component of the impact of the climate system plays a significant role in the global climate change. The Paris Agreement provides unique opportunities to organize the solution of environmental problems using market mechanisms. The country's participation in the flexible mechanism of the Paris Agreement can become a real factor of the economic growth, a prerequisite for the successful implementation of the mechanism of the Paris Agreement can become a real factor of the economic growth. At the first stage, we formulate the main assumptions regarding the subject of the study. The producer operates in a perfectly competitive environment. The production capabilities of the set of producers are given by their total production capacity the maximum possible output per unit of time. The only product factor is labor force. According to the neoclassical theory of production, we will describe technologies and production capabilities by the production function. This represents the dependence of the maximum level of output on production capacity and the amount of involved production factor. Producer hire labor on the market. The labor is offered by the population. This is also the main consumer of the product. In order to study the level of the national strategy, the optimal development problem is formulated based on the introduced assumption with the optimal criterion, which represents the maximum value of the specific consumption of the population during the planning period. In this case, each producer is characterized by the equation of reproduction of the main product capacities and the assumption the investment are fully spent without taking into account the delay in the increase in the main production capacities and on depreciation deduction at a known level of product capacities in the base year. Production capabilities are given by the production function, and the entire gross output of product is distributed between intermediate and final consumption, economic and ecological. The environmental or ecological limit on greenhouse gas emissions is introduced as the difference of two components: the volume of emissions, which is considered proportional to the volume of the released product with a coefficient, and the volume of destroyed population proportional to the value of environmental costs with a coefficient. We will reduce the proposed model to the corresponding model in relative indicators. The study of the model is based on the apparatus of the theory of optimal control and allows you to determine stationary trajectories. In particular, the system determines the switches point of the model. The model has three development modes dependent on the ratio of parameters. B and P, and also allow you to determine stationary trajectory. We research three scenario: P more than B, P less than B, and P equal B, and stationary state of the model. After considering the
I'm very sorry, but you have 1 minute left. Can you please rush a little?
Okay. After considering the equations obtained in PS, it becomes possible to determine the optimal control and stationary value. The control determinant and phases variables are the maximum of the integral final consumption and the volume of gross output the model under study. We conduct model calculation based on the proposed single sector ecological and economical model in order to specify its exogenous variables. We use conditional values. Given the known values of the phase variable and the control of the stationary trajectory, we determine the values of the specific variables on the stationary trajectory. Output per employer, per capita final consumption, volume of specific capital forming product, environmental cost or ecological costs, capital requirement. The latter allows us to move on to the main endogenous variables of model. Thank you for your attention. Any questions, please?
Does anyone from audience have questions for this presentation?
I can ask one question. Can you mention one more? Maybe it would be several parameters which are affecting mostly for the model.
Yeah. In model, we research switch point with dual variable or parameters, dual variables p with equivalent parameter dynamic of main economical hypotheses with economical output. And we researches this parameter with exogenical variables b, and discuss three different variants of development our system. First variant p more than b, second p less than b, and three variant p equal b. And in these researches, we determined stationary state trajectory this determined by system on slide 12.
Thank you very much for your answer and for your presentation. Let us proceed for the next presentation with ID number 184, Abdelkader Birouchedi from University of Paris, Paris 8. Okay.
Thank you.
You can start. Yes, we start.
So today I will present work. So the goal is here is how to use data from the data from the connected vehicle. So the goal is to improve road safety and improve the insurance prices for China. So the project is from PSA. PSA is project in French, like Hyundai, like Nissan. So they have all the vehicle connected. This connected vehicle gives us a lot of data. This data is stored in unstructured big data in Hadoop, in databases SQL or SQL. So, but the real question is how can we use this data in a smart way? So how we can with this data give offer prices for insurance or personal safety or get information from this data. So what is the goal? The goal is to improve the driver in some clustering and to say the profile of of each group. So for that we can have a lot of groups like aggressive driver, discredited or caution, but there is more type of driver. For that, we must use clustering. So clustering is unsupervised learning because in our data we can have a lot. For that, we have many algorithms. So the overview of our method. So from our infrastructure big data, we have a lot of data providing structure or infrastructure. So we use Spark and Python to prepare this data and to clean. After this data is stored in databases like Cassandra. After that, we train some model like Canyon, like DBScan. So many algorithms for clustering. We validate the result and interpret this what means this result in the file. So the data we have 100 1 to 1,200 driver. So all data is full anonymized because in Colombian GDPR we cannot use the real data. For example, for vehicle speed, we cannot use. We say this driver has 20 or 100 speed limit, so we have a range. We must anonymize this. For example, for GPS coordinate, we don't use the pure GPS coordinate. You can say it's in this area or in this zone. So we have a lot of work to anonymize all data before make the question. So we test a lot of algorithms, but in a final we find the Canyon is better. So first, how to determine the optimal clustering of Canyon. So we have the method, LGRU method, that the uploader like this that can go to give us the optimal clustering. Here is the value. So as you showed, don't yeah, the clustering we have the clustering yellow is the driver aggressive. Second discussion driver pushes the driver or discarded driver. So we have the three cluster, but we have some outlier in with this so with this system, how you can use it? We can use it for assurance. So with the shortest pay as you drive, because we want the driver, good driver, why he pay same as a very driver. So you pay your insurance as your driver is a good driver, why you pay so we can use it for route safety. And we can also use this solution for management that optimize for company. If the company has many drivers, the cell can give the permission or for good driver or supervise the unprovided. So the sound and the future work is also to respect GDPR and to store and secure this data and integrate some future like media, like visibility to get a real environment for this study. And we can also use another algorithm like deep learning because we have a lot of data. And finally, so we can say our solution This demonstrate we can get a group of driver and we can use it for. It's really used with assurance for pay as you drive as offer for driver.
Thank you very much. This is very interesting and actual research area for researching behavior of driver. And could you maybe not direct question, but could you assess some, for example, this aggressive driver and not aggressive, very good driver, and what is the probability to get car accident with this side or second side? It depends because it may be good driver with good behavior, but the probability of accident will be the same as for the dangerous.
I are good driver in the States, but I am not a good driver. So I am the cause of an accident. So it's difficult to predict.
But such resources will help such.
Yeah, but we can.
Okay, thank you. Yes, issue is.
Accidents, hotspots, where the most accidents will happen and happen.
No, the data is collected in normal situation. There is no accident. Therefore, data is there is no accident. So all data is in a normal situation. For accident, yes, here. So here we with the course of the surf, so we can predict the accident if you see visual speed 2000 or G or brake using. You a lot of brake, you can predict the accident.
Personal use of vehicle.
Okay, then. Thank you.
We kindly ask all the next presenters and participants to follow with time regulations. We are in time shortage. Thank you. Unfortunately, we proceed now with presentation ID 194.
Time flies so.
This is the topic of my work, deep learning based level detection and comparative analysis of CNN architectures. I have this one. I'm sorry. Thank you. Let's go back straight to introduction. Apples are a crucial part of global agriculture, with big portion of imports and exports overall in the world, including Kazakhstan. And sometimes it faces problems of apple diseases, which may cause from 20 to 40% of losses every year. And for now, the practicing solution is manual inspection by experts, which is slow, subjective, and expensive. And now, in the time of trending of ML and DL techniques, it is a push to have a sense to implement these technologies also in this endeavor. The aim of this work is to develop and implement a robust machine learning-based system for the accurate and timely identification of apple diseases using CNN architecture models. With these objectives listed below, these research questions. Related work. Several papers were analyzed and reviewed during the study, and there are four most related for the study and with or almost with state-of-the-art results. They are also going to be illustrated in discussion bar. Methodology consists of 3 slides, 3 parts. First is data collection. The plant village dataset was chosen for this work due to several reasons. First of all, it is that this dataset is trusted, and second of all, several related works also use this dataset. This dataset consists of 3 types of disease apples and first apple, Appelscat, Blackrod, and Ceteris. Model selection. At the very beginning of the study, deep CNN and white-way CNN was compared, and it was decided a deep CNN architecture over white-way CNNs due to majorly for high performance accuracy and architecture flexibility that it can provide. Chosen deep CNNs are AlexNet, ResNet, and DenseNet. Model training. As you can see in this figure, there is algorithm of the model training, which start with data processing. Then retained models are used. I want to highlight that every model was used separately and trained also separately. Then fully connected layers was applied with raw activational function. Then Adam optimizer was chosen for this project with learning rate from 10 in the square of -3 down to 10 square of -5 with a batch size of 32 to match with my GPU. In every epoch, there was first from 1 to 15 epoch, and in every epoch, several metrics were analyzed and observed. Their accuracy, loss, learning rate, recall, F1 score, and precision. Results. Well, first of all, in the first figure, we first run 3 models on 15 epochs, and as you can see, the set model got highest accuracy, and therefore we go with this model on 30 epochs, and it showed benchmarking more than 99% of accuracy, 99.35, with F1 score of 0.993. Discussion. Before going to main discussion, let me talk a little about ResNet model achieving so low accuracy. The possible reason for that is choosing Adam optimizer. Also, it is one of the good optimizers. Several studies also found out that it is better to use with CGP instead of Adam optimizer. In this table, it is comparison of our work with other similar works, and as you can see, our work. 1 minute. Okay, I'm finishing. Our work got recording accuracy, and the reasons for that it can be first of all we focus on deep CNN architecture, while others emphasize white-way CNNs. Also, our dataset is more balanced. And comparing with Sai and Patil, we use it more DL architecture, which are more trending. So in the end, before conclusions, there are some future directions. First, applying self-supervised, semi-supervised, featured learning methods to utilize and handle data effectively. And second, shift research efforts to disease management strategies and early inventions in real-time conditions. And overall, we build algorithm with what can break 99.35% of accuracy using the model DenseNet. Also, it was compared with AlexNet and ResNet, and this is the dataset that we used. This is references, and thank you for your attention.
I'd like to ask the audience if anyone has any questions for this presentation. Can you elaborate on the limitations of the work that you had during the research and how did you handle them?
Okay, that's good one. Well, Usually other works also discuss about time consuming, while in my case, I have struggled with computational power as I use my own laptop. Limitations also, I can point on datasets, even though there are many good datasets, but as I wanted to focus on Kazakhstan's problem, some climatic change and geographical factors may be differ, like in terms of identification. Therefore, in future directions, I recommended to increase this one. Yes, I think.
Thank you for it.
Thank you.
If there are no more questions, we can proceed with the next presentation. Thank you for it. Next, we would like to ask ID number 204, Inara Kaibasova, to present.
Даниил Ганиулов, да?
Yes.
Okay.
So, our goal is to relate to your discussion with natural language processing algorithms. So, to consider the relevance of this topic, the first one is that, since educational materials sometimes after some period can become old, so they're supposed to be updated. So, therefore, if we compare the disciplines that just current materials and those that have in the past, they can have a big difference. So therefore, it should be considered that these materials should have improvements and updates. And the second one is that in order to meet the market demands, since the demand can change all the time on the annual basis, it also requires for this material in higher degree institutions to be relevant and actual to the current standards. So the aim of this research was one of the steps is to identify the keywords that will be used for educational content generation. So the content will be created depending on the keywords, and the list of keywords will be formed after processing the data set. So about the practical significance, we collected the data set that includes 5 course syllabuses. There are ways to computer science or any other areas, for example, project management and etc. So those tools that we are using over here is eBird, TF-IDF, and yet another keyword extractor. So the list of topics, and also the description and the course one for 10 weeks for the entire course were selected in order to be processed inside of the database. So we get the process of keyword extraction both on the basis of statistical analysis, deep learning, also graph-based. So the first one was eBird. It works with the semantic analysis and it's based on the BERT language model. So the cosine similarity works the Q-roll over here. It compares what kind of value can be relevant in terms of the context. So it uses the embedding vector, their products, and also the division by the absolute volume. And the second one is the term frequency and inverse document frequency. Also is a statistical based tool. So it uses how frequently, for example, one term can be mapped inside of document and how it is relevant to the area. So over here it also takes the evaluation based on specific documents and market it, also the full value. And the equation shows what kind of frequency can be mapped in terms of the keyword. And the one that was also statistical is yet another keyword extraction. So over here it works not only with frequency, but also the word prediction. What part of the sentence it is, what kind of case values does it have, and what kind of story bank of the word. So according to this formula, the value of word will be also shown. So considering the entire process included the data sets that was processed, but before doing that, the pre-processing step was also crucial. After that, the precision someone. So each instance had analysis. After that, the input was shown as the list of keywords. According to the graph, it shows that the another structure has more great result in comparison with the other two tools in terms of semantic relevance and also the content. And here are the performance metrics. So over here we can see that in terms of precision and the transport, there's another tool that has great results. And the conclusion is that we'll use this tool, this Blackboard tool, for the further steps of our research to generate educational content based on the list of tools that we treat using this algorithm. Thank you for your attention.
Does anyone from the audience have any questions for the presenter?
This very interesting research topic, and
What can you elaborate more on like future prospects of your research? How can other architectures or
Okay, so in terms of the other architectures, also there are like graph-based tools, but sometimes the accuracy cannot be accurate compared to these tools. For example, statistical versus embedded. So therefore, this tool for sort and just about the future perspectives, what will be in the future. And so we'll use the list of tools that we found after processing this synopsis to identify and to create, for example, new topics that will be included in new educational disciplines in terms of computer science, also in other areas that have their classes as resources.
thank you. Please let us move to the next presentation, ID number 212. Виталий, да? Виталий Лесневский.
Hello everyone. Today we will present you our research topics. Using Linux as a method of defense against attacks. So today is the main problem is that every hour a new cyber attack is exist, but only in 1 week security defense is updated. So it's creating a very big gap. And today I will explain you how we can help this with Linux tools with open source. So let's go. So the first problem, how I think, is the cyber attacks is very fast and usual. So to protect us, we will create 4 metrics. So the first one is NEC, how many risk ports are open in our host. Next one is CVSS, is about how serious vulnerability of the system is. And the next one is Interport. It's just like password change, and Discourse. It's like live traffic anomalies. So our objective is reduce the cyber attacks about below 20% for SOA. So the first our method is using different Scala Linux tools. It's also free and open source. So for our research, we use virtual machine that's launched about 2 CPU cores and also 4 GB of RAM. So deploy it very fast, and it shows that good defense don't need very expensive hardware. So for the attacks, we use different tools like SQL injection and something like that. And for protection, we use in common IP tables and fail to ban. So the next algorithm is the main algorithm is 6F. It helps us to detect the attacks. So the first one is the scanning networks using the tool that I explained before. The next one is we plan the attacks by control and safety. Then we just check how its attack is going and analyze them. The fourth step is partner our project to flow some force and edge filters. Then we just monitoring what is going on with their scopes and take some clusters with comings. And then we test to see what is changed and if our host is stands much safer. And about the cycle of our algorithm, it's about 25 minutes to slow networks. And also it helps about to decrease attacks by 8%. So I trust extend your vulnerability analysis algorithm. It just looking for some different anomalies in our host or JSON files or configs in our host. So then it's just analyze them and deploy fixes. And the next one is anomaly detection algorithm. It's using Wireshark packets to collecting the data from the different attacks. Then we are analyzing them with coming groups to make it like one cluster. And then we are using Discourse to see what's going on. And to block some attacks, we using fail2ban and also IP tables. So like a result, after all our attacks, equals 9 attacks, we are increase the security of our host by 80%, and the best one was 91. Also, we decrease the SQL injection by 3 injections per second to 0.34. So it's all. Thank you for your attention. For questions? Yeah.
Please come closer to the microphone.
What to think about the new version of Kali Linux, Kali program? It's aimed for SOC analysis.
I think it's new version is more priority for security, I think, and analyzing what is going on host on servers, like analyzing big configs or syslogs, like this one. And also, you asked about new version, yeah?
Kali program.
Kali.
Yeah.
Huh?
Yes.
We don't work with this one. We work is more latest version because they're more stable and have open source tools like this one.
As you know, Kali Linux is aimed for impression data and other things, but the new version of Kali program is changed for that.
Yeah, of course, they're using for defense, but it can be used like not only for defense. It's using different tools. Just we don't know really they are. For example, we are analyze the K-scopes clusters to see different syslogs while we're using attacks like DDoS or just DDoS. So it's useful now, but in the latest version, it's more like just analysis, not like auto response of the problem.
Thanks for that presentation. So we will proceed with ID 220 presentation, and due to time constraints, the presentation ID number 228 will be conducted after the coffee break. So we can proceed with presentation number ID 220.
Okay, hello. May you stop? Okay.
You can start your presentation.
Can you, do you see my presentation?
Yes. Can you also turn on your camera, please?
Okay. Give me a minute, please. So, hello, and my name is Saltanat Mangarieva. I'm a master's student at Astana IT University. So, my theme is IoT-based smart work control, enhancing energy efficiency with AI. So, the main motivation is that HVAC systems account for 30–50% buildings' energy use. So smarter control promises tangible economic and environmental gains. So here the key questions which I answered during my work. First is, can random forest improve the accuracy of temperature, humidity, and the energy consumption predictions? How adaptive is the system to fluctuating indoor environmental conditions? Can the proposed method outperform existing solutions based on linear regression in the neural networks? So here's the main system architecture of my work. Here we use it for the sensing. It's Aqara temperature and humidity sensors, which streams indoor data via Yandex IoT Hub. So next one is data fusion. We enrich these readings with Yandex Weather outdoor data to build a unified feature set. The next one is ML Core. I choose random forest. I will say why later. So random forest with 5-fold cross-validation for rapidness. Next one is cloud layer. All raw data and the forecast and are mirrored to the ThingSpeak and database, which enabling live dashboards and the remote diagnostics. And the last one is control loop. We decide to control or no control to our AC. And why is random forest? For this, I use the database which are published in Kaggle. So it names as HVAC dataset. So here you can see the
I'm sorry, no.
Okay, so I choose 3 models to compare between each other. It's a linear regression, random forest, and the neural network. From these comparison models, you can see that random forest have best results for my future work to identify indoor temperature in my home. So now I'm collecting real data in my home from the sensors and also the Yandex API weather. So this how random forest is predicted my temperature, which will be in indoor after 30 minutes. So we can clearly see that random forest works really well. So here's the prediction MSTR error. Also, it near to the 0. So for conclusion, it's control system based on random forest algorithms. So showcasing its effectiveness and optimizing indoor climate. So next steps is including to another sensors like CO2 or occupancy. So also adding online learning so the model can self-adapt and conducting all the seasons, because I tested only this only a short season. So this is my reference. Thank you so much.
Thank you. Like as for Q&A, I wanted to ask, why did you choose exactly these three models or algorithms? What was the motivation behind selecting those?
Yeah, I have only one system that I need to control. If we will add another systems, not only AC, like I don't know, to increase humidity or occupancy. So we can use another complex models for this for my little database and for little indoor occupancy. I choose these three models.
Thank you very much. That was very valuable information. Thanks for your time.
Thank you.
Can we we're going to proceed with the next presentation, ID number 228.
Technologies.
Yes, okay. So yeah, there's a forward button. This is forward.
Yeah, usually.
Okay, great. Okay, so it's a pleasure for me to be here in Astana. Thank you for selecting the paper. I want to thank all the committee members. They put a lot of work. My appreciation. That one. So I'm going to talk about machine learning for healthcare cost prediction. This problem is actually specific to USA because there is no national health system. You have to pay for your medical costs, procedures through your insurance company, but nobody knows how much it is going to cost. If you go to the hospital with some condition, you can end up paying $1,000 or $100,000. Always a mystery. But we feel that today, in the world where we can find the price of everything, what is taxi ride, what is a plane ticket, what is shopping, you can compare all the prices. This is one area you cannot compare anything because not enough data is in it. So my work is aimed at trying to address this problem. Okay, so healthcare cost transparency is critical at that. Fortunately, there are some data sets. The state of New York, I live in New York State. The state has released a lot of information about patient costs and outcomes. It's free data, but it is limited. So the detail is not there in the data as much as we would like. So we don't have blood pressure, medication information, and so on. It will just tell you demographic information. What is the patient's age roughly? What is the race? What is the gender? How did they pay for the treatment? What insurance? Different surgical outcomes, severity of illness, length of stay in the hospital, and so on. So I'm using all those things. And the research question is how can we predict the healthcare costs and how can we enhance price transparency? Okay. So the framework that we're using is to develop better models. So in the past, you just have one single model is doing the prediction and you can get errors. Okay. So we came up with a different type of prediction where we not only have the value, but we also decide the expected variance in that estimate. And if the expected variance is very high, we say we cannot predict. So it's like fuzzy logic in some sense. You have confidence associated with that estimate. And you say like, okay, I will not say what this cost is going to be because I don't know. But other costs, you can say, yes, I'm very sure I can get this value. That's the basic idea. So here's the flow of information. You read the data, you split the numerical values, categorical values. So we analyze those. And then we train the XGBoost model. And we also use the CatBoost ensemble. So we have two ways. So the CatBoost ensemble will use about 10 different estimators. And we find 10 different models. You look at the standard deviation. And if it is high, we say, okay, you will not predict. Okay, and they're using the standard machine learning technology with training data and testing data. We cannot train and test on the same data, right? So split it in 20. And here are some of the results we get. So there are some cases that we say we don't predict. So we look at two models, one which is using predictions, and the other one which is not using certain predictions. And we find that the distribution is very similar. So we like to get a model where the accuracy is high. And so we have two models, model 1 and model 2. And we want to compare the errors. And you can see that here the errors are segregated by age group. So age 50 to 60, most of the errors are there because this is the age group where a lot of health conditions get complicated. So there is variation in the estimation. Whereas age group 18 to 29, you don't have, or age group 0 to 17, there's not that many cost variations. So it's more accurate predictions than we develop. So that is the basic idea here. So we can improve accuracy of our prediction by using two different models. And then you can see it's a trade-off. There's a coverage. If you want to cover all the data, you don't want to eliminate any possibilities, then error can go up. The mean square error will go up because you're trying to predict some outliers, and it's always difficult to predict cost outliers. Okay? And if you don't mind the lower coverage, in fact, the curve is very steep. So if you're willing to give up, say, okay, I will not predict 10% of the data. I'm willing to predict 90%, but I get better root mean square error. Okay, so that's all I have. And you can also say how much data you can remove. So you can remove data initially. You can remove the outliers first, and then do the prediction, or do the prediction and remove the outliers. Okay, so there are two different techniques that we use. Okay. And so basically we see that the model estimation has a confidence associated with it. So it's a flexible trade-off. You can decide how you want to deploy the model in practice. And it mimics post-op rejection. So you can reject the samples after you create a prediction and say, okay, I will not report this value. It's an internal limitation in the model. And so the limitation of this study is it's free public data. If you're willing to pay money, $10,000, $100,000, you can get much more accurate data. Okay, but this work is done in like a public service kind of work. It's open source. The data, people can replicate the model, they can compare results. And I think it's the only way to improve cost efficiency of the system. Otherwise, insurance companies keep all the information. And you know what happened last year? United Health CEO was assassinated still. And today, news is that United Health is being investigated for criminal injustice, like they're not doing their work properly. So it's a developing field, and I thank you for your attention.
Even though this is open data, as you say, and maybe some information can be not sufficient to analyze, but your research fills the gap for this question, I think.
Yeah. Thank you. I have been doing it for a few years, and people are definitely welcome. If you have any questions, I have all the listed to the data set. You can also download and play around with the data. There are about 2 million records over the last 10 years. We've got 20 million records. Good data. Very well. Yeah. Question?
Thank you. Could you clarify what was the dimensionality of your input data?
Pardon me?
How many features did you use in your analysis?
The features? Yes, we used
the number of features.
Yes. So I mean, so there are we used everything except total charges because there are two columns. One is total charges and one is total cost, which are relevant. But the charges is what the hospital will give the insurance company and ask them to pay. Like the charge is, let's say, $5,000. They'll say, I will charge the insurance company $5,000, but insurance companies usually give less than that. They'll give $1,000. So you cannot actually use total charges in your model. It has to be only the total cost. And they have features like length of stay, illness. There's a medical coding, like 256 clinical classification diagnosis codes. There is a severity of illness codes. There's age, demographics, like the race of the person, and even the name of the hospital and the county. There's a lot of detailed info. So we use all of that information in the model. Yeah.
Okay, thank you.
You're welcome. Yes. Thank you for your question. Yes.
So I also have a question.
Yes.
Which machine learning models give you best result in predicting healthcare's costing?
Yes, so we use that boost here. So we tried that. We have not compared. This is a preliminary study. We have done some work. Last year, I have a journal paper. We used different, like we used, regression and we used linear regression. Actually, linear regression can be very powerful because you can use lots of parameters in your model. 1,000 linear coefficients. And we found them good. Also, one more thing I did not explain, these models have to be interpretable. So you want to explain, if you find a result, you have to say, why is your model doing this? You use like neural network, you cannot tell. It's like a black box, you cannot explain why this feature is important or not. Okay. Yeah. Okay, I hope it answers your question. Yeah.
Thanks very much.
You're welcome, you're welcome. Thank you. And yeah, I appreciate your help. Just closing. I know, yeah. I know it's not easy. I have also run conferences and I've seen there and all. It's very tough to execute, but this was good. And you did remote also. Very nice. Good job.
Презентация неден не ма? Өзіңіз қойып ма? Сентеден.
Қазір тексерістер келеді. Dear participants, we start in few moments, please. ID number 253, Jenis Otarbay, Afzal Kazakhanov, are you here? Marjan Aliaskar, Talgat Mazakov, Aygrim Mazakova, Sholpan Jomartova, are you here? Aruzhan Burambekova, Pakizar Shamoy.
Hello, I'm here. Can you hear me?
Yeah, Aruzhan, please, are you ready to present your
Yes, I'm ready.
paper? Okay, thanks a lot. Please share your screen.
Can you give me 1 minute, please? 1 second. I will. Can you see my screen?
Yeah.
Okay. Hello everyone. My name is Aruzhan Burambekova, and today I'm gonna present our work titled Comparative Analysis of Color Models for Human Perception and Visual Color Difference.
So for the introduction, color is not just a physical phenomenon, it's deeply tied to human psychology, culture, and even emotion. So, however, translating human color perception into computational models is incredibly challenging. And for example, in digital design, two colors might look identical to one person, but noticeably different to another. So similarly in quality control for manufacturing, and even slight color mismatches can lead to rejected products. Current color difference metrics such as delta E in CLAB and other standards are widely used but don't always match human judgment. This misalignment can cause problems in industries where color accuracy is critical. So our study aims to bridge this gap by evaluating how well popular color models such RGB, HSL, CLAB, CLOOP align with actual human perception. So a little bit of the models what we choose. For the first one, we chose well-known RGB additive color model with dramatic theory of vision. Next one was XYZ, the fundamental color. Actually, the standard, which based on human color measure experiments, and serves the foundation of many color models. Next one was Famous Lab. It was designed for perceptual uniformity with different characteristics and structure. And it's widely used in industries like textiles and printing. Next one was CLAV, and it is like similar to Lab, but optimized for additive color spaces and displays. The last two was HSV and HSL from HS family, two cylindrical models. So they are more intuitive for designers. Each of them has own strengths, but their performance in matching human perception varies significantly. So actually, we used some standard color difference formulas. So this is examples of them. So the methodology of our work, it combined human evaluation. Actually, from the start, we chose 20 color pairs with different wide range of hues, saturations, and brightness levels. So we used human perception survey. For the first step, we recruited 15 participants aged 20 to 23 years old, and asked them to rate the perceived differences between those chosen pairs. And the second part of work was to evaluate the difference mathematically. So firstly, we converted the same color pairs into our chosen pairs, and on each of them we conducted the calculation of the color differences, and then we got the result table. And this two-pronged approach ensured our findings were both mathematically rigorous and grounded in real human perception. It's like a picture, for example. So, and okay, actually, key results are we we studied the coloration of our results, and HS family color models showed the most the best results, 72 and 60%. CLAB underperformed despite the theoretical advantages, and RGB and others were showed the first alignment. So, and for the future works, we aim to larger participant pool, a broader age ranges, and actually extend the color stimuli per the tests. So, thank you for your attention. That's all.
Thank you, Arjan. So, questions, please. I have one question. Why did you use correlation? What kind of correlation did you use in your study? Pearson correlation or Spearman, or maybe other type?
Pearson.
Do you consider to use another type of correlation? Because sometimes we know that Spearman or Pearson correlation is not good for such measures. So, what are your plans about this? Did you analyze why this type of correlation is not good?
Okay, we consider your thoughts and about
Okay, that's not a question. Maybe it's just a suggestion. So thank you very much for you. Now we should pass to other report.
Plans actually about to. Thank you.
Okay, thank you very much. So now the next speaker is ID 253, Deniz Otarbai, Aksunayt University, in the Nazarbayev University.
They are not available. They are not available. Are we? Okay.
Good afternoon, dear participants of conference. My name is Almas, and I will present our work about improving predictors of output-based emotional recognition by using transform methods for subject-independent classification. Let's start from motivation. Emotional recognition helps machine understand how we feel, but traditional methods like speech or facial recognition can be fake and there a little bit lack of accuracy. So EEG is more reliable because it records the real brain signal. But the main problem of these models can be used for different people. So we want to change this. Here is our research objective. First one is combine CNN and transform C1 model, then make model work for everyone without using by specific peoples. Third one is based on real data sets, and finally make sure that it could be work in real time. Next one is awaited goal. So we showed it. Older models use CNN and RNNs. They're good for use in EEG, but for example, CNN needs time-based changes, and RNN understand that time is a little bit slow. So transformers are efficient, it can be parallel and handle temporal EEG complexity. So we use CNN and transformers together. To train our model, we use SID4 dataset. It contains EEG and eye tracking. it has 4 emotions: happy, sad, fearful, and neutral. And it will be very useful that understand it. Our model will work with 4 different people. Here is our proposed architecture. Our architecture starts from CNN levels to find pattern in EEG. Then we use transform levels to understand the timing and flow of these patterns. And finally, it makes prediction about the emotion. Here is our evaluation methods. We have on the floor accuracy, our under the curve, precision, equal transport, and confusion methods. Now let's go to the result. Here is our validation set and result for the. For example, in validation set, accuracy is 0.96% and accuracy is 0.91. Here is precision and dollar fun and subtle for every, I would say, emotion. It's related to validation data set. And for test set, accuracy is 91%. This and the two is around 96%. And the confusion methods are this one. We have some problems about, for example, validation set is fair and happy. It was using help on right because it's the same going signals. And in that step, we have to improve this, and especially for fear and happy. And here we also we have a result for this. And for future, we can say that we created models that go, I think, a little bit perfectly, but it's not should be personal kind deliberation, but it contains only 4 basic emotions. It's, I would say, is our limitation for our model. And like future direction of this, expand for multi-data sets, reduce model size because it's very big and for real time it will be very, I would say, slow and improve model interoperability. And here is our conclusion. This is later.
Thank you. Thank you very much. Questions, please? Okay. Можете пройти сюда вот? Микрофон.
You said that your one of the main metrics was accuracy, yes? And my question is about dataset. You know that accuracy is not quite good in unbalanced datasets. So in your dataset, are the features are balanced or not?
Actually, we have 4, how to say, training and some validation used SC4 dataset, and for my scientific supervisor, Jenny Sotomayor worked in Northern University. They have EEG equipment, and he tested it by himself.
Wow. Makes sense.
Yeah.
Thank you very much. Any question?
Another question do you have?
Thank you. So please.
So next speaker will be ID 258, Marjan Aliaskar, International Engineering and Technology University. Are you here?
Yes, I'm
No.
here.
Okay. Okay, can you in this case share your screen?
Yes, 1 minute.
No, 1 minute, 1 second, please.
1 second, okay. Can you see my presentation?
Yeah.
Yeah.
You can start.
Okay, my name is Marjan. I'm a doctoral student. Hidden repeating patterns appear in many real-world datasets, sunspot counts, heartbeats, stock prices, speech signals. Why does this matter? Because uncovering these patterns can improve forecasting of solar storms and natural disasters, enhance medical diagnosis in EGG and ECG enable smarter financial analytics, and boost speech recognition reliability. Unfortunately, common tools like FFT, wavelets, or pure machine learning often fail on noisy or unevenly simpled data, and different applications demand different methods. Our goal is to develop a single robust algorithm that can find hidden periodicities across a variety of noisy real-world time series. As you can see from this equation, our approach is based on iterative harmonic selections. First is initialize the harmonic count, j equals 1. Second, fit coefficients, ag and bg, to minimize the least squares functional. Third is compute errors, if it exists, the three holds for epsilon, increment j, and repeat. First is terminate when adding more harmonics does not significantly improve the fit. Implementation notes. Written this our algorithm written in Python with iterative command list input of single text in line, one data point per line, outputs both a text file of numerical results and a plot of the fitted series. In first figure, first we tested on monthly wolf sunspot numbers. The algorithm extracted a dominant cycle of t equals 127.2 months, and this matches known long-term solar cycle and validates our methods on geographical data. And second, next, we processed audio recognition from 50 students, each saying the numbers 1 through 10. We converted WAV headers into amplitude time series, applied our harmonic fitting, and extracted 10 voice features. Our method achieved 70 and 72% recognition accuracy on this task, demonstrating its utility in speech analysis. Solar cycle, I said this, and results. First, proposed methods accuracy is 72%, and the Fourier transform 68%. Wavelet analyzer is 70%, and random forest 74%. And you can see complexity and noisy sensitivity. Our approach strike a balance of competitive accuracy, moderate computational cost, and a strong robustness to noise. We developed a single optimization-based algorithm that uncovers hidden periodicity in both single and multiple signals, validated on solar activity data and student speech with strong results. For the future directions are integrate deep learning techniques to further improve accuracy and adaptivity, apply to rapid response neural disaster monitoring, and massive analytics. Prototype a microprocessor-based access control device using our algorithm for real-time operation. And thank you for your attention.
Thank you very much for your presentation. Questions, please. Okay, I have one question. Did you use any benchmark to compare your results, or just only your own your own baseline methods?
Can you repeat? Benchmark?
Yes. Did you use any benchmark from the field?
Sorry, I can't answer to this question because since our professor couldn't be present today, I will be able to answer this for this question.
Okay. Thanks a lot. So we should listen to Dias Ilyas. Aygul Mimbaeva. Are you here?
Yes.
Okay, thank you. Please.
For the researchers, my name is Dias, and I am going to be for the researchers, my name is Dias, and I'm going to introduce my paper named Neuronism for IELTS writing evaluation. The problem scope is, you know, that in our country, many students are passing IELTS tests every year, but manual evaluation of IELTS writing, especially writing 2 section, is very costly, time consuming, and subjective, maybe inconsistent. So there is a need for automated, tailored, and reliable system to evaluate this IELTS writing essays. And in this program, we can rely on NLP and deep learning because they are offering some promising solutions. The main objective is to develop neural network with using Python BERT. We used the model because there was a need for transformer model to understand the semantic endings of the essay, because essays are may differ from the topics, like example, advantage, disadvantage, maybe problem solving, and so on. So there was a need to use transformer model. Then with the help of transformer model, we develop neural network, and our model will automatically score IELTS write +2 task essays and evaluate on 4 criteria as being official scoring criteria. That it's a task response, case confusion, lexical resource, and grammatical accuracy. We searched for some similar researchers in this field, so the choice of BERT wasn't just random, because other researchers also offered used BERT model because it gives us contextual understanding of essays, classification, and good for classification and regression tasks. And the other models like GPT 3.5 also reinforcement learning models, smart assistant, and education tools were not used because there was lack of resources in training, and just like other researchers, we relied only on BERT model. So the dataset for this for training this model was obtained from Kaggle platform, where we found 800 essays, 800 only essays, and the dataset was split. 10% of the essays were to test, and the other 80% was split training, and the other 10 for validation. Here you can view our architecture of neural network, where input layer is our essays are passed through BERT embeddings, where our essays are tokenized. Then they are by the help of CLS tokens, there will be understanding of semantic meanings, and in our layers, through our layers, essays, tokens of essays are passed, And by the help of evaluation and the dropout, we will train to output 4 evaluations like fast response, rigorous cohesion, and the other metrics. So in training setup, there were used Adam W optimization, optimizer, and the loss function. For loss function, were used mean squared error because we have 4 criteria for this evaluation task. So the loss function of mean squared error was the best function. Okay. Here, results of the training. You can see that over 50 cycles of training, the accuracy of model are rising, and the loss curve is dropping down. And here you can see that, as I said before, 79 essays were chosen for test set, and here you can view the actual and the predicted results predicted for 4 series. And the main insights, the Pearson correlation were used to evaluate like linear Pearson correlation were used in our evaluation because this model, this evaluation method is best fits since we have 4 evaluation criteria, and the strongest point was in fast response, rigorous cohesion, and so on. And in conclusion, we can say that BERT-based models are effective in this task, and there was quite limitations like dataset diversity and the model interpretability. And in future work, we want to use larger datasets and explainable AI approaches. So, thank you for your attention.
Okay, thank you very much. Questions, please? Okay.
I was wondering if that's very good work because it reduces the subjectivity of the essay evaluation. I was wondering if you have considered or if it's possible or what are the limitations of doing this for the oral test, the speaking test, which is also a very time consuming and money consuming test.
Yes, we might do some research in this book because in our research, our essay evaluation is about NLP. Yes, oral is also NLP, but there in oral evaluation might be used some different models. So yes, quite good insight. It's interesting topic for further development.
Lot of people say this is the most money consuming part of the IELTS test actually.
Yes,
So
right.
Thank you for your question. It's really a valuable insight. So I have question. What is the difference between cohesion and coherence? And who did annotate your dataset from Kaggle? Were they valuable and valuable teachers, or maybe they experts in this field?
Yes. First question was about what is the difference of coherence and cohesiveness. So I'm not qualified English teacher, so I cannot answer the question briefly. But main difference between coherence and cohesion, it's like I might be the natural writing of the author, but this is not the final answer. So might be the right answer might be different from my answer. And the second question was about work with experts. No, there was no works with experts because our data set is quite small. But in the first development, we want to work with experts because the small data set is a limitation of our work. And by using larger data set and by validating it in real world IELTS centers, this is the main part of future work in our paper.
Yes, thank you. Thank you. Do you have? Okay, another question.
Does your model use IELTS task prompt to evaluate the essay? Does your model use task prompt in IELTS? Or where said write about something and does model use this prompt from IELTS to evaluate the essay?
Yes, in our architecture, you can see that the input layer, it's a layer where the whole essay with a question will be passed through this layer, and our BERT transformer model will understand the semantic understanding of this task, and its understanding helps us to evaluate this essay. So the answer for your question is
Okay. Okay, thank you. Do we have any questions? No. No? Okay, thank you very much. So the next speaker is ID 273, Ertuğrul Sert, Ankara University. Are you here?
No. No.
No? Okay, so let's move to the next. The next speaker is ID 283, Sultan Aubakirov, Astana IT.
Oh.
During the audience, today I'm going to present the development of stock market prediction model for Kazakhstan's market. After this, Sultan, everyone. First of all, in Kazakhstan, the investment market is in rise. So the statistics show that in the first quarter of 2022, the individual growth was 44% growth in the market. So the problem that our market does not have specific sentiment analysis tools who are going to. So we're going to evaluate how news headlines impact the stock market in Kazakhstan and how do traditional models compared to performance-based models understand sentiment of the news headline. This review we review three types of model. First of all, random forest is a assembling algorithm that uses decision trees to evaluate and classify data. Also, we use logistic regression as some base model, and also bidirectional embedded models named there. This is a transform-based model, which is state of art of today's NLP task. So also we reviewed some other models for sentiment analysis, such as FinBERT. First of all, FinBERT is a classic model for evaluating sentiment in the news. It uses three-stage learning. First of all, in general purpose, then in financial purpose, and then learn to classify data. And they use financial trade bank as a data set. We also use the same tactic, and first of all, yes, collect the data from the news and the news newspapers, and then created a 3.7 million tokens data corpus. Then labeled these data set based on the sentiment using Google Gemini, and also we combined it with a rational labeled financial use data set, and we use also the main adaptation for mask language modeling, and then trained model for specific fine tuning, such as sentiment classification. Also, we combined with traditional ML models, we use TF-IDF, which is a simple way to recognize text, which gives us the vector that indicates how each word from the text impact to another. And with the TF-IDF, we use logistic regression and random forest, as I said before. Models for transform-based models, we use three models: Tiny Bear, and Roberta, which is small base and large models. And also we mask 15% of input tokens for mask training and 5 false. And in the second stage, while we learning to classify the data, we use 3 apples with batch size 10. And also for evaluation with accuracy, precision, recall, and F1 metrics. And results. First of all, the dataset shows that in this picture you can see that the dataset have 8,000 rows, and there you can see the distribution of where the natural, positive, and negative. Also, there you can see model learning and models results are shown in this table. First of all, the best model was the base, which is give us the balance between computational efficiency and performance. And also we analyze the chart, analyze the sentiment of Kaspi.kz news, and in this graph you may see the correlation between rise of negative news and negative impact of the stock market. And for future work, we are going to use this LSTM. We are going to use this sentiment analysis model combined with LSTM, which is neural network also, to use this sentiment analytics for prediction stock prices. And,
Okay, thank you very much, Sultan. So, questions, please.
I have 2 questions. First one is more about technical. You said that you have used BERT-based model, yes? You know that in BERT-based model, it has cased or uncased version. So which cased or uncased did you use?
Oh, we use QMask model, and then use and then add a final classification layer that give us percent, is it negative or positive or neutral?
No, cased uncased model. It's cased model. It tokenizes uppercase like uppercase and lowercase as lowercase.
We use uncased, which do not see the cases, but all in text are lowercase.
And the second question, much broader. Your model evaluates the news and evaluates the effect of news to stock market. Yes. And did you have cases where fake news affected the stock market?
No, we didn't evaluate this case. Only the base. But I think fake news have less impact because real news appears in many sources, in many newspapers, and they have better impact.
Okay, thank you for
So, okay, one more question is, so is your data set given in Russian or in Kazakh language?
It's given in Russian because in Russian we have more data.
So in this case, is it possible to optimize your model, like to translate automatically and run for another languages also?
I think yes, but I need to collect the corpuses for Kazakh language instead of Russian, because in this case we collected Russian news only.
Yeah. Okay. So I mean, if you add here some functions like to translate automatically and the text in any languages, is it?
No, we need to fine tune every time for
Ah,
every language.
Okay, thank you. Is there any question? No? Okay, thank you very much, Sultan. So the next speaker is ID 288, Sultan Guljan, Astana IT University. Guljan, are you here?
Kairbayev.
Okay.
Second.
Okay, author, yeah. Okay, Yurnar Kairbayev, Astana IT University. Let's start.
Hello, dear colleges. My name is Yerna Kairbayev. Allow me to present the paper on application of hybrid deep learning architecture for analyzing with disease. With
Excuse me for interrupt. Could you please turn on your panel? We couldn't see you.
Okay. Which remains key group for global food security, but sector striped rust and brown rust. This is cause significant field losses and increased crop protection cost every year. Advanced in deep learning techniques have opened up the possibility of automating the diagnostics of these diseases by analyzing digital images of leaves and ears. The greatest progress has been made by convolutional neural networks, which can accurately extract local textural features. However, CNNs often face generalization problem when dealing with noisy field data. In parallel, vision transformers are gaining popularity in computer vision by moving in attention mechanism from natural language processing to image analysis. They flexibly evaluate the global context of a frame going beyond local filters. By combining ResNet 50, which captures small patterns in detail, which VITB16, which captures relationships at the whole image level, we form hybrid architecture that combines the advantage to both approaches. We anticipate that this hybrid model will outperform both classical CNNs and pure vision transformers in terms of accuracy and reliability in with disease diagnosis. In recent years, ResNet, EfficientNet, and MobileNet have become the de facto standard for plant disease diagnostics. Shows up to 95% accuracy is laboratory kits. In the field, however, these metrics drop due in controlled lighting and complex backgrounds. Vision transformers, on the other hand, is robust to contrast and backlighting, but sometimes loses small fuzzy. Some work has shown that an outer is some initial research is direction full flagged trials on the area still rare, and we are continuing to work in this direction. We combined three public dataset and obtained about 6,000 RGB image. Each frame was manually inspected and categorized into 4 classes. Weighted random sampler was used to deal with imbalance. To train the model to see symptoms under all conditions, we applied advanced augmentation, reflections, rotation, brightness, and contrast fluctuations, perspective distortions, and Gaussian blur. The architecture is arranged as follows. The output vector of local ResNet 50 features is combined with the global VIT embedding when passed through this compact layer classifier. The model has trained for several dozen approaches on a modern GPU using mixed precursion and adaptive optimized with dynamic scheduler, which accelerated convergence and reduced memory overhead. All experiments were logged in White and BSS and interpreted with GradCam and UMAP. In addition to the hybrid architecture, we separated, trained, and tested populate baseline models: ResNet, EfficientNet, MobileNet, VIT, Swintini, in classic CVM, and Random Forest. On the sample, the hybrid model achieved 93.8 accuracy, 93.7 F1 score. The table's result is shown in this slide. Healthy and brown RAS are categorized almost without error. The main misses are the confusion of Satori and striped RAS, which is expected due to similar symptoms. GradCam showed that the network does look at necrosis spots and rust pustules, ratchets, and background areas. We plan enrich the dataset with image of local weight varieties reflecting in external characteristic in different disease resistance, cover all stages of plant development from seeding to milk maturity, including period of drought, salinity and sharp temperature fluctuations, supplements in materials which have perspectral and multispectral images to recognize subtly early signs of infection and impacts the set diagnosis by adding Ocher visit disease. Synchronous model forecast with stations and IoT sensors, generating a multivariate risk model that provides advanced warning of likely disease outbreak for particular field variety. The summarize the CNN transforms hybrid confidence, outperforms single networks, and remains stable even with dirty field data. Optimization for edge platforms and integration with the IoT ecosystem will make system practical full farmers, helping reduce crop losses and chemical inputs. Thank you for your attention. Sorry,
Thank you.
camera.
Thank you very much. So now questions, please. Okay, we don't have any questions. Thank you very much.
Thank you.
Then, okay, thank you. The next one is the ID 295, Olena Varbasa, sorry, Ukraine.
Here.
So, please share your screen and you can start.
Yes, you can see.
Yes.
Yeah. Okay. Good day. My name is Elena Vartsaba, and I am a postgraduate student at Uzhhorod National University. And I will present our paper on some approaches to solving the Dedekind problem. The authors are Igor Mech, Volodymyr Nikolenko, Elena Vartsaba, Nikita Kogut, and Alexander Kuchansky. The class of monotone and self-dual functions is the most potent class among other classes of functions of two-valued logic. Monotone Boolean functions are used to solve various discrete extremal problems. When formulating the problem of calculating the cardinality of the class of monotone Boolean functions of n variables, we set the goal of finding exact formulas for their calculation. Finding the cardinality of this class is problematic since the number of monotone functions skyrockets with increasing n. Therefore, this problem was solved for one subclass of monotone functions, single-tier deadlock disjunctive normal forms of n equals 1 to 13. In 1897, Dedekind solved this problem for n equals 4, and in 1940, Church for n equals 5, and Ward for n equals 6 in 1946. The values of the Dedekind number of Boolean functions of 7, 8, and 9 variables are now known. Wiedemann calculated the number of monotone functions of 8 variables and gave algorithm for computing n equals 8 in the context of that theory. All elementary conjunctions and all disjunctive normal forms are monotone functions. A deadlocked disjunctive normal form of a monotone functions is called a disjunctive normal form, in which no elementary conjunctions is the proper part of another elementary conjunction. Deadlocked disjunctive normal forms are canonical. And deadlocked disjunctive normal form of the case order is called disjunction of elementary conjunctions with rank k. For example, expression of the form by 1 is the deadlock disjunctive normal form of the third order, and expressions of the form by 2 of the fifth order. The cardinality of a deadlocked disjunctive normal form is equal to the number of disjuncts of the disjunctive normal form. For example, for cardinality of a deadlocked disjunctive normal forms by 3, I equal 3 and 2. Let us denote by 4 the set of deadlocked disjunctive normal forms of n variables of the ith order with the rank j. We write out all elements of the set of deadlocked disjunctive normal forms of 4 variables and find formulas for finding the cardinality this set. Deadlocked disjunctive normal form is called a single T form if it is a disjunction of elementary conjunctions with the same rank. The number of single T deadlocked disjunctive normal forms for 4 variables is 19,4 and is calculated by the formula of 5. Generalizing the considerations given for n equals 4, we obtain the formulas by 6 for calculating single T deadlocked disjunctive normal forms for n variables. Due to well-defined nature of the single T deadlocked disjunctive normal form set, the software to calculate its cardinality was relatively straightforward to implement with following considerations with further execution on a regular PC. Python was used as the primary language with built-in support for arbitrary site integers, which is essential for the provided formulas implementation. Recursion in binomial coefficient calculation was still limited for performance reasons. All calculated values were cached with Zuzig pairing functions as a hashing algorithm. A built-in concurrent model was used to split computation over multiply CPU cores. We obtain the results for all n values from 1 and to 13, given in table 1. The first column indicates the cardinality of the class of single T monotone functions for n from 1 to 13, and the second column indicate the power of the class of monotone functions that are currently now. Monotone functions of n variables can be defined on the vertices of n dimensional cube. A theorem is given that decomposes the monotone functions of n variables into 2 classes: the monotone functions of n-1 variable and the monotone functions of n variables that label only the variable x1. Second method for computing single T deadlocked disjunctive normal forms is proposed using this theorem. The developed program confirmed the coincidence of the results of calculating single T deadlocked normal forms by 2 different formulas, 7 and 6. The paper shows that for n equals 13, the number of single T monotone Boolean functions is more than 10 to the power of 518. Therefore, the problem of calculating the number of monotone functions, finding the Dedekind number that scientifically exceed the number of single T deadlocked disjunctive normal forms is not promising. Another way to find the Dedekind number is to divide the set of monotone functions into classes of functions that are multi-tier disjunctive normal forms. The following paper plans to study monotone functions that belong to several tiers of the n-dimensional cube, and this paper proposes two methods for calculating the number of single T monotone functions. Thanks for your attention.
Okay, thank you very much, Olena. So do you have any questions, please? Okay, now in this case, I will ask you, so can you again explain the application of your model, where we can apply it, and what kind of, I don't know, properties we will get from applicating your methods into your tasks? Where we can apply your model? So I know that four-dimensional cases, it's very difficult, I know that. And how did you reduce unknown coefficients here, variables? How did you get your results?
Okay, if I understood correctly, this only one class which we can calculate cardinality with class monotone functions, and the Dedekind problem is very important and problem in discrete math and math logic, and for our scientists, it's very difficult to perform it, to calculate, to find the number of single-tier deadlocked disjunctive normal form, and we use combinatorial formulas, and we
Okay, thank you very much. So when you implement it in Python, what kind of methods did you use to solve your problem? You said that you implement it in Python. So did you use some types of methods, or there are maybe set of functions of Python?
Okay, I can hear you and didn't understand. Can you repeat your question, please?
So, okay, in your presentation, you said that the Python was the first implemented program, yeah?
Yes.
Okay, so in this case, did you apply it under did you implement it in Python by a certain type of methods, or is there any type of set of functions models in Python?
No.
Okay. So, okay, and another questions, please? No?
May I ask? Hello, you have mentioned that you have tail eliminated binomial coefficient recursion in binomial coefficients, yes, for performance reasons. Can you? The question is, in this performance context, do the compiler handle it automatically, or you just optimize your performance manually?
So here, coefficients. About the question is about coefficients. So, did you give the values for your coefficients manually or optimize it? Yeah.
No, next slide maybe.
Next slide.
Optimize, yes, optimize.
Optimize
And,
manually. Yeah?
Okay, okay. Thank you very much, Olena. Thank you for your presentations. Yeah, goodbye. So the next speaker is ID 296, Madina Junusova, Gumilev Eurasian National University.
Hello.
Hello. So please share your screen, your presentation, and you can start.
Okay. Hello, Chairperson and members of the Commission, as well as conference participants. My name is Madina Junusova. I am a PhD student at the Gumilev Eurasian National University. Special attention should be paid to reservoirs which can be artificial or natural. These objects play a key role in regulating the hydrological regime of a region, providing water resources for population and industry and preventing floods. This slide shows the goal and the key objective we aimed to achieve. There are several major platforms that provide access to satellite data, such as Google Earth Engine, NASA Worldview, Landviewer, and others. Each of these platforms has its own features and advantages. However, in our study, we chose the Landviewer platform as it offers an intuitive interface that allows for efficient searching and filtering of images based on specified criteria. Using this platform, satellite data were collected for the period from 2000 to 2024, utilizing missions such as Landsat 7, 8, 9, and Sentinel-2. One of the key components of the system is the use of computer vision. Computer vision to analyze satellite images, which allows for accurately identifying change in the surface area of water bodies. For this person, we developed an images processing method using the OpenCV library, which includes color filtering in the HSV space, hue, saturance value, and subsequent contour detection to isolate the wet surface. Another method used in the study is time series analysis using Fourier transform algorithms. This approach helps identify key trends and cyclic change in the data, which is important for long-term monitoring and forecasting. The collected data are used as input parameters for machine learning models developed with TensorFlow. These models analyze historical data on the surface area of a reservoir along with monitor meteorological conditional, allowing us to predict possible change in their size and state.
Madina, sorry, are you changing your page for presentations? Because I think we stay on the page methods and you didn't change anything. Is it okay?
Excuse me?
Слайды вы меняете, нет?
Нет. Я меняю, да, меняю.
А у нас нет. Мы видим страницу, где у вас мезок только.
Сейчас, минуточку.
Вот, introduction видим, первую страницу.
Вторая. Да, то есть второй слайд introduction, да.
Да. Третью.
Methods.
Method, yeah. After that, did you change?
Continue, please.
Okay,
Дальше
you can.
продолжим.
Yes, continue.
Так, methods. These models analyze historical data on the surface area of a reservoir along with meteorological condition, allowing us to predict possible change in the size and state. The use of deep learning methods, particularly neural networks, helps reveal complex relationships between various factors affecting the state of water bodies. For classification, machine learning algorithms were так. Вот. For classification, machine learning algorithms were used in particular the random forest algorithm, which was trained on data that included year, months, and season features. Further image processing was carried out in the Jupyter Notebook environment, where the main tool is the Python programming language, which has a wide range of libraries for scientific computing, visualization, and data analysis, such as NumPy, SumPy, Matplotlib, and Pandas. The images were divided by season: spring, summer, autumn, and winter, based on the specified HSV thresholds. Masks created to isolate water surface. This thresholds select experimentally for is water related color depending on the season and the characteristic of the satellite image. After the mask is created, contour detection is performed to identify probable boundaries of the water surface. At the final stage, the largest contour analyze, which considered the main boundaries of the reservoir. The area of the largest contour is measured and converted from pixels to square kilometers, which allows for accurate estimation of the reservoir's connected size. During the research, we encountered the following difficulties. Difficulties when collecting data from is Landview platform for the period from 2003 to 2015. Some images content interface in the form of parallel stripes, which
You have 1 minute.
Minute, okay. Signature computing, the processing of creating mask and calculating water area. Next, results during processing of satellite images divided by season. The water surface areas were calculated based on the MNDWI. For the calculation, the SWIR was used, which provide a more accurate detection of water bodies in built-up and mixed landscape. Three reservoirs were selected as object of Stede Badam, Shardara, and Kirov. The graph demonstrated the change in reservoir area over the years. Result classification.
Time is up. Move to conclusion, please.
Result conclusion.
Yes.
The calculation in this study in analysis of reservoir area change was conducted using satellite data to totally 501 images. Classification of area change using machine learning algorithms such as random forest allowed us to identify two types of changes, significant and insignificant over the past 22 years. The results showed that for mouse reservoir, the model successfully handled the classification task, although there were difference in prediction accuracy depending on the reservoir. This findings emphasize the importance of using satellite technologies and machine learning for water resource monitoring.
Thank you very much. Questions, please? So how many classes did you explore in your research?
Explore.
You conducted classification. So how many classes?
Classification classes. The classification accuracies show high performance, and the model with a 5% area change threshold was able to accurately classify the change is significant.
Your input features, I'm sorry, your input features, year, month, season, and area. What is your output classification labels?
Сейчас скажу.
Okay, that's okay. So thank you very much. The next.
Okay, thank you very much, Madina. So the next speaker is ID 300, Ajar Tursunova, Al-Farabi Kazakh National University. Ajar.
Ajar is not available.
Okay, in this case, let's move to the next speaker, who is Zeynel Momunkulova, International Information Technology University. ID is 302.
No one. You see, there are no speakers.
So can we finish?
Yes.
So for today.
Yep. Okay. We should finish our session. So thank you very much for all presenters. Thank you very much for all listeners, for all participants. We wish you all the best. So we meet you tomorrow at 9 o'clock morning
and at 10 o'clock.
10 o'clock. Okay. Thank you very much.